Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for Honda CR-V models from 2023 and beyond. In this presentation, we will focus on diagnosing and resolving DTC codes P032F-92, which indicates an engine stall, and P2D28-92, signifying a cold start engine stall. It's crucial to understand that these codes are stored in the Powertrain Control Module, PCM, when the engine exhibits abnormal operational behavior soon after starting. The PCM monitors various engine parameters and can identify faults, triggering these DTC codes when it determines that the engine stalling is outside typical operational conditions. We will be going through each aspect of the troubleshooting process, from error descriptions to detailed steps, to ensure a successful resolution. DTC P032F-92 indicates an engine stall, which is identified when the engine fails to continue running under specified conditions. The component primarily involved in managing the engine's operation is the Powertrain Control Module, PCM, which is responsible for monitoring numerous parameters like fuel flow, air intake, and engine speed. The typical location of the PCM is within the engine compartment or passenger cabin, aligned with the vehicle's wiring harness for efficient connectivity. DTC P2D28-92 relates specifically to engine stalls that occur during cold starts, denoting a possible inability to maintain idle speed in colder conditions. Understanding these codes is crucial, as they alert the technician about an abnormal condition that needs immediate attention. It's imperative to accurately diagnose the root of the stall to prevent further issues down the line, especially in new model vehicles like the Honda CR-V. Several possible causes can lead to the DTC codes P032F-92 and P2D28-92. One of the primary suspects is a faulty Powertrain Control Module, PCM. If the PCM malfunctions, it may inaccurately assess conditions and fail to provide optimal fueling and air intake, leading to an engine stall. Another significant factor can be issues with the fuel supply, such as a clogged fuel filter or failing fuel pump, which can hinder the engine from receiving adequate fuel during startup. Additionally, airflow restrictions due to a dirty air filter or malfunctioning mass airflow sensor, MAF, can disrupt the air-fuel mixture needed for combustion. It's essential to consider these components step by step as they interplay with each other and can contribute to engine failure. The symptoms associated with DTC P032F-92 and P2D28-92 manifest in several ways that directly affect vehicle operation. Primarily, drivers may experience unexpected engine stalls, particularly shortly after the engine is started, which can pose a significant safety risk during operation. There may also be difficulty starting the engine, especially in cold conditions where the vehicle may struggle to maintain idle speed and operational consistency. Additionally, idling issues could emerge where the engine may not sustain a stable RPM, causing fluctuations that indicate underlying problems with fuel or air delivery systems. Recognizing these symptoms is critical for early diagnosis, and actions should be taken promptly to address these issues to prevent escalation. In the first troubleshooting step for DTC P032F-92, you need to start the engine and maintain the engine speed at 3,000 RPM. This should be done without load, meaning the vehicle should be in park, P, or neutral, N. This scenario is crucial because holding a higher RPM without load allows the engine to reach operational temperature and engage various sensors, facilitating a proper operational assessment. You'll want to continue this process until the radiator fan activates signifying that the engine has reached a certain temperature threshold. Once the fan turns on, it indicates that the cooling system is operational, and the next step involves letting the engine idle for a period. This initial check helps ensure that any existing faults are observable under controlled conditions before proceeding with more invasive diagnostics. Once you have completed the first step successfully, you will turn the vehicle off, putting it into off lock mode. This is essential to reset any temporary faults or conditions that may have been present during the initial engine operation. After ensuring the vehicle is completely off, you will restart the engine. At this point, it is imperative to let the engine idle for at least 20 seconds, which allows the PCM to reassess the engine's performance under these new conditions. The idling period enables the PCM to check for any abnormal behavior, which may not have been apparent under higher RPMs. Observing this behavior also allows you to confirm if the stall occurred immediately after starting or if the problems manifest over a short period. For troubleshooting DTC P032F-92, the first step involves leaving the vehicle in the off lock mode for a minimum of 6 hours. This waiting period is strategic as it allows any potential residual issues within the engine's management systems to settle and clear. This time frame ensures that components that may have been affected by temperature changes are allowed to reach normal operating conditions again. Such a procedure could also reset any lingering faults logged in the system, thereby providing a clean slate for more accurate diagnostics upon engine restart. The significance of this approach is critical for diagnosing cold start problems, as it creates a consistent baseline for testing under cold conditions. Ensure that the vehicle is indeed left undisturbed during this duration for best results. After allowing the vehicle to remain in the off mode for the stipulated 6 hours, the next step is to restart the engine. Immediately upon starting, it is crucial to let the engine idle for at least 20 seconds. This action is vital for checking how the engine behaves immediately after cold start conditions. During this irreplaceable window, the PCM evaluates parameters about the cold start performance, validating whether the engine maintains a stable idle speed and assesses if further issues arise. The importance of this step lies in its focus on validating that the engine does not stall under idle conditions right after a cold start, which is integral to resolving the DTC effectively. Careful observation during this idle phase will provide insights into whether the problem persists or if the initial fault has been resolved. After conducting all the troubleshooting steps, it is crucial to perform final repair verifications to ensure that the issues related to DTC P032F-92 and P2D28-92 are completely resolved. Begin by performing any final checks related to the components and systems inspected during the troubleshooting process. After confirming that all related repairs and checks are satisfactory, utilize an appropriate diagnostic tool to clear the DTC from the PCM memory. Following the clearing of the codes, it is essential to conduct a test drive under varied conditions to evaluate the engine's performance. This drive will help confirm that the repairs have been effective and that no further DTCs are triggered during operation. Properly completing these verification steps provides assurance of the integrity of the repairs made. To prevent future occurrences of engine stalling related to DTC P032F-92 and P2D28-92, regular preventive maintenance is essential. One fundamental aspect is to conduct regular inspections of the fuel system, ensuring that the fuel pump is operational and the fuel filter is clean and unclogged. Restrictions in the fuel flow can lead to severe performance issues, resulting in stalling phenomena. Additionally, Checking the air filters routinely is vital, as dirty filters can restrict airflow into the engine, affecting the combustion process. By maintaining these components consistently, drivers can significantly reduce the chances of encountering similar DTCs in the future. Proactive checks also ensure the vehicle runs at optimal performance levels, contributing to longevity. In conclusion, diagnosing and resolving DTC P032F-92 and P2D28-92 is crucial for ensuring your Honda CR-V functions effectively. These DTCs indicate serious engine stall conditions that must be addressed promptly to maintain safety and performance. By following a systematic troubleshooting protocol, starting from engine observations to final repairs, technicians can accurately identify and rectify underlying issues. Furthermore, incorporating preventive maintenance measures, such as routine fuel and air filter inspections, can extend the overall life of the vehicle and maintain its reliability. Ultimately, consistent attention to both diagnostic and maintenance practices will provide a smoother driving experience and diminish the chance of future occurrences of such DTCs. Please like and subscribe to the channel. See you next time!